Assalamualaikum warahmatullahi wabarakatuh. We are from grade 18 and we got to represent our group assignment and this is all our group members. In our case study, we need to develop a new pump that will assist in pumping water from the river of White Tank. They include 0.53 of fluoride. Also, a small pipe with a diameter of 15 centimeters and length of 20 meters is being considered. These are the conditions that have been stated, and when we examine the river water's properties and the surrounding environment, we discover that it is 27 degrees Celsius, has a density of 996.52 and a dynamic of 0.008052, all of which are dependent on temperature. According to the literature review, the reason for using a typical pump in this case is that it require less maintenance. It is capable of pumping large volume in a short period of time. It is capable of working in any head condition from medium to low and is capable of working with low viscosity of fluid. By rotating the impeller, a centrifugal pump increases fluid flow. Rotational energy is converted to energy in order to keep up with the increasing velocity and pressure. Pump theory is used to determine the performance parameter of pump, which is head, power, efficiency, and flow rate. The head, power, fluid velocity, efficiency, head loss, and Reynolds number are all equations that are used in centrifugal pump. By deriving the head from the parallel rule, we have this formula. By applying Euler velocity triangle formula to the turbo machinery, we obtain this formula. According to the slide, this is all the formula that we use in designing our pump.
Assalamualaikum. My name is Tuan Muhammad Farhan, metric number DD 2009. So I'll continue to the design specification part. The purpose of the project is to design a pump which can transmit water from a river into an empty tank. The empty tank is 10 meters vertically above the river, indicating the 10-meter difference in water level in between river and the tank. The pipe's diameter is fixed at 0.5 meters with a total length of 20 meters. System expected to operate at volume flow rate of 0.573 meter cube per second. Values for the parameters listed in the first table, which are bounded by a minimum and maximum value, must be configured. We can say this is the limitation of the pump. So as you can see at the top of the slide, this is the example for the asphalt cast iron, which is chosen as the pipe material for the piping system with surface roughness 0.00012 meter. The temperature of the water is fixed at 26 degrees Celsius for calculation purposes, which resulting in dynamic viscosity 0.8732 times 10 power of negative 3, and density of water is 996 and 85 kg per meter cube. Considering all parameter limitation, we've selected water temperature, dynamic viscosity, and density of water. Values for these parameters are set for pump design specification, which can be described in the second table. This green color of table shows the chosen values for parameters in designing the pump impeller.
Hello and Assalamualaikum. My name is Irfan Iqbal bin Muhammad Asri and I will explain about calculation. So first is the calculation of a piping system. First step, we use the energy equation to determine the head of piping system. Energy equation is given by below, which is P1 per rho g plus V2 per 2g plus Z1 plus head pump equal to P2 per rho g plus V2 per 2g plus Z2 plus HL. Then when we refer to the equation, we assume that the container of tank is closed, so the pressure will be 0 and the velocity will assume as 0, same as the P2 and V2. So we will get the 0 plus Z1 plus head pump equal to 0 plus 0, Z2 plus head loss. So after we arrange the equation, we will get the equation which is head pump is equal to Z2 minus Z1 plus head loss. Then next, as Z1 is the height of the height at river, which is 0 meter, and Z2 is the height of tank, which is 10 meters. The equation can be derived into head pump equal to tank plus HL. So next, the given volume of flow rate is 0.573. The diameter of pipe is 0.5 meters, and velocity of the flow can be determined by using the equation given below, which is V equal to QA, which is V is the velocity, Q is the flow rate, and A is the area. Then we just insert the value that have been given. Then we will get the answer, which is 2.9235 millimeter per second for velocity. And then to find the Reynolds number, we need to use the equation of RE equal to rho VD per nu. For your information, the Reynolds number is used to determine the friction factor of flow. And then we just insert the value have been given, and we will get the Reynolds number is 1.712 times 10⁶, which is the RE number is exact the value of 400. And then we can assume that the Reynolds number is a turbulent flow. Okay, next. After we have know that the Reynolds number is the turbulent flow, we have to use a Colebrook equation to find a turbulent flow, and to find the friction, which is the F. Okay, so we assume the pipe is smooth, so the roughness will be 0 for the calculation of the friction factor. And then after we assume that the pipe is smooth, so the roughness it will be 0. Then we just insert the value in the equation again, and then we will get the F is equal to 0.010631. Okay, after we have get the value of the friction, then we can calculate for the head loss. Okay, next for the head loss, we have the equation below, which is HL equal to V2 per 2G times FL per D minus KL. Okay, for the value we have searched before, and then we just insert the value, which is V2 is the velocity, and then we just insert the 2.9235, and then 2G and FL per D, which is F is the friction that we search here, and then we just insert into the equation 20 is the L, and D is 0.5, which is diameter, plus KL. KL is the pin for each elbow. So 0.5 times 5 plus 0.05 times 2, and then we will get the head loss is 1.3178. Okay, next. So after we get the value of the head loss, we will just to insert the value into the equation 4, which is the equation before is HP is equal to 10 plus HL. Then we just search for the HL before, and then we just insert back into the equation and it will be HP is equal to 10 plus 1.3178, and the total of the value of the head pump, it will be 11.3178 meter. Okay, after we get the head pump, we will as the end of project, pump have 30% of tolerance, which make head pump system to be at 130% at maximum and 125% at minimum. The calculation of maximum and minimum tolerance of head pump is given by 130 per 100 times 11.3178, which is it will be 14.7131 meter. And then the second one for 125%, it will be 14.1.725 meter. Okay, that's all from me. Thank you.
Hello. I will now continue to present about calculation for centrifugal pump. So we will continue with the calculation for the next slide. So the calculation for centrifugal pump, we will start by determine the head pump from the formula given. HP equal to 1 over G U2 times VT2 minus U1 times VT1. So where G is the gravitational acceleration, U2 rotative velocity outlet, VT2 velocity tangent at outlet, U1 rotative velocity at inlet, and VT1 velocity tangent at inlet. Then we can produce or draw the velocity triangle at inlet of pump impeller, and we can put the what needed in the drawing, like in the figure 3. After that, we will find the value for U1 using formula 2 pi n over 60 times R1. Then we put the value in the formula U1. Then we get 2 pi times 2500 divided by 60 times 0.1, and we get the answer 26.1799 meter per second. And after that, we calculate the velocity inlet, VN1 by using the formula Q over 2 pi R1 B1. So we put the value for each parameter. So we get 0.573 divided by 2 pi times 0.1 times 0.03. Then we get 30.3986 meter per second. Then we will continue to calculate velocity tangent. Velocity tangent VT is given by equation Vt equal to U minus X. So U in this case is the rotative velocity. However, to get X, we can use the velocity triangle. Based on the velocity triangle, we can get by using Pythagoras theorem, which the equation is given by tan beta equal to Vn1 over X. So we can derive from the equation, then we can get X equal to Vn1 over tan beta. So to get the value of X, so we will use Vn1 and beta 1 value. So we put the value into the equation for x1. So we can get 30.3986 times over tan 50 over divided by tan 50. Then we can get the value 25.5075 meter per second. So we can get value Vt1 by using the formula Vt equal to U1 subtract and minus x1. So we 26.1799 minus 25.5075. Then we can get the answer for Vt1 0.6724 meter per second. After that, we can draw another velocity triangle, but at outlet of pump impeller. Then calculation for outlet part in the pump, which consists of U2, Vn1, X2 and Vt2, can be calculated using the same method like in the inlet part. From doing the same calculation but with different parameter, we get that U2 equal to 31.5159 meter per second, Vn2 equal to 25.3322 meter per second, X2 equal to 25.5097 meter per second, and Vt2 equal to 5.9062 meter per second. So from the calculated value, we can substitute it into equation to get head pump. So head pump equation, HP equal to 1 over G U2 times Vt2 minus U1 times Vt1. After obtaining the value for that fourth parameter, then we substitute the value into the equation. So HP equal to 1 over 9.81 in bracket 31.4159 times 5.9062 minus 26.1799 times 0.6724. Then we can get the answer 17.1198 meter. Then we will calculate the tolerance of pump of HP is given by H pump equal 17.1198 over 11.3178 times 100% equal to 151.26%. Then we can calculate the power of the pump by using the formula PW equal to H pump rho GQ. So power of the pump, PW, equal to 17.1189 times 996.85 times 9.81 times 0.573, equal to 95.929 kilowatt. That's all from me. I will pass for my friend, teammate, to present the others.
Bismillahirrahmanirrahim. My name is Muhammad Zahim bin Jamsari, DD190015. I will be conducting the part 8 for discussion in this project. So mainly for the discussion, we are actually focusing on the calculation that we obtained from the for this project, and then before we go through for the calculation project, we'll also be discussing on the reason between the reason that we get and obtain the value in the calculation. So in this discussion, we'll be focusing on three things, which we're going to focusing on. First is the specification, and then the second one will be the parameter, and then we have the material, and lastly we're going to be talking about the calculation what we obtain and what we can understand. Okay, alright, so the first thing we're going to talk is going to be our project design, which is our design specification. Our design specification is the first one, that the tank must be placed on the top, and it has to be bigger than the trough that's supported, because the reason is because we need to have high pressure water to be transmitted to the resident area, so really need it very to place it correctly. So we use 5 90-degree elbow and 2 global valve. This is the, well, actually the function is to change the flow and also to stop the water stream wherever. So next is the material for the pipe. So we choose the cast iron as our material of the choice. This is because cast iron is low noise and then also high corrosive resistant. And then it's also quite surprising is they also really good because they also had a better heat resistance. And for us to discuss this, we thought that this really suitable to be used in Malaysia. Because the concentration, the temperature, and the weather in Malaysia, so we thought the cast iron will be perfect for our pipe. So the next thing that we need to consider is the parameter overhead, which was parameter overhead. We're gonna be discussing about the weather in pipe Raja, which is the place we're gonna to put the tank on. The weather play a significant role in temperature. So temperature will be deciding with we talk about temperature is gonna be talking about the viscosity and also the density. So why this is gonna be the one who make us problem and troubles us to make sure the water to pump able to pump water to the area. So yeah, this parameter is very crucial. The weather, determining the weather is very crucial in our designing, so we don't have any in high head loss, and also pump able to function very nicely. So after this consideration, this is the value that we obtained. The head pump is 17.1201, and then the optimum range after we set the tolerance between 1 to 5 to 130%. This is the value for the optimum range for the head pump system. And then after we calculate the head pump system, we're gonna find the head pump power. So this is the final power that we obtained, 35.929 kilowatt. This is the final value that we obtained from after we make some considerations, some designing in the specification. This is the value that we get to able to measure the pump, able to pump the water to the people in the residential area. So this value is the value that we needed to pump operate, so we can able to pump to the people. So that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Finally, this investigation yields several conclusions. The project's goal was to investigate and show the starting performance of a prototype centrifugal pump that transmit water from a river into an empty tank. Several calculations and designs performed based on the understanding of the idea of turbo machinery. The problem solved after a few computations and discussions with the teammates and lecturer. In addition, knowing how to create the appropriate sort of pipe for the constraint that the chip requires. Thus, carry out as much calculation and findings of the problem makes things even more clear about to achieve the desired heat pump. The more calculation and data are to be carried out, the more could be understood to obtain the results and build a pump that meet the requirement made by the chief engineer. So that's all from us. Thank you very much.